The transmitter module in here is another state machine that basically takes some data that you're trying to send and just shift it out like on the TX line in here. It is very similar to the receiver part in here. So I recommend that you watch the receiver part first before you watch this video. Anyhow, so the transmitter, how does it work? Well, it's a finite state machine that pushes this data at 16 baud rate. So let me just show you the ASM or the ASMD chart for that matter. And the ASMD chart tells me, well, the transmitter, according to this one here, takes this as an input, the Duntic. I'm not showing the inputs and output, but you can see it in here. This is an output, this is an input, this is an input, this is an output, and we can see those. But anyway, what it tells me, it also, similar to the receiver, it has 4 states. So I have a state in here, I have another one in here, and I have another one in here, and I have another one in here. They have the same exact names as the receiver because, again, it's the same thing but in the opposite direction. So idle, start, data, and stop, the same exact thing. But what happens in here is you're shifting the data. So instead of detecting the middle point of a bit, what you're trying to do is you're just trying to maintain it for 16 bits. For the receiver in a different system will actually figure out the middle point. All right, so let me just walk you through this diagram very quickly. So what does the diagram tells me? So in an idle state, if you are in an idle state, what it tells me is the following. Here I have an output. So let me write these here on the side. Okay, so in here, let me just do that. So I have TX, and TX is actually just the output here, that line here. Okay, and I'm just gonna basically keep it at what I'm saying in here is you should keep it at 1 in an idle state, because remember the UART protocol tells me in idle the transmit or the line between the receiver and transmitter should be kept high. So I'm saying, well, you should keep it high. Well, you should keep it at high, and then you should ask yourself, is TX start equals 1? Remember, the TX start equals 1 tells me that I have a valid data in here that I'm trying to send. So if that is 1, or if it's not 1, you just stay in idle. If it is 1, then you go in and you say, okay, I'm going to say S. And again, S is the number of S ticks. Okay, the number of how many ticks did I receive. I'm just going to put a 0 in it. And then what I'm going to do is I'm going to say B. B is actually the register that I care to shift out. Okay, so this is the shifted, well, the bits to be shifted now. It's not the shifted because I'm shifting them out. Bits to be shifted, okay? To be shifted in here. And what I'm saying is go to this port in here, which is TXDN. Okay, I didn't call it TXDN, but I should. It's just whatever the N is. And you just basically read it and load it in there. And of course, whatever that value is, let's assume that you shifted this value in here, 1, 0, 1, whatever it is. And basically, I'm just telling you, just store that in the B because we're going to shift it 1 bit at a time through the TX line in here. All right, and of course, that tells me also the next state should be the start state. So, okay, we're going to take to the start state. Again, the start, remember the start bit is actually what I keep the value of the line at low for 16 times the bit, the baud rate, okay? So what I'm doing in here, and I'm telling you, well, the transmit line should be kept at 0. And what I'm doing in the next few questions, I'm asking, well, is S tick equals 1? If it's not, you do this. If it is true, you're asking yourself, is it 15? So here I'm not trying to detect the middle of the point. In the receiver, we tried to detect the middle point and we reset it and we moved on because we're trying to figure out the middle point. In here, I'm trying to keep it on or to keep it held at 0 for 16 times the baud rate in here. So I'm going to ask, is S equals 15? Remember, S is the number of S ticks. If not, I'll just add a 1. I'll just add a 1 till I reach the 15. When I reach the 15, I'll make S equal 0. And again, I'm going to use the same exact N that we used before. N is the number of bits to be shifted, whether the data bits and the parity bits and so forth. And then, of course, we have the next state in here, which is data. So what data does is actually puts on the transmit line, which is the TX in here. It will actually just take B0. And of course, B0 will be shifted along, and you're going to see it in here. We shift the B. All right, then it asks, well, gonna be the S tick, and again, just like we're looking for 16. So once if it's not 15, you just keep adding 1 to that S. Once it's 15, you do the following: you zero that again, and you shift the B. Basically, what I'm saying is, you take this particular one in here, this one. Let me just do that. You're going to take this one in here, you're going to put it on TX line. It's like, well, I shifted 2 bits, but anyway, you get the idea. So we're going to take this 0 in here, we're going to put it in here, we're going to keep it. Once we're done with it, what we will do is we'll actually take that B in here and we're just going to shift it. And of course, by shifting it, I'm telling you, drop that lower significant bit out, and that will become the lower significant bit. And then you're going to ask yourself, did I shift all the bits in here? If not, I'll just add another one and repeat. Of course, I'll be shifting the other one in here. I'll put it in here. Once I'm done with that, I basically, this question will be true. That means I shifted all the content of B out, and now what I need to do is I need to generate the stop bit. And remember, the stop bit should be kept at high, okay, for SB tick. Remember, it's like the SB tick could be 16. If it's 1.5 would be 16 plus maybe 8, and then 2, which is 16 plus 16, which is 32. And then at the very end, I'll just generate the tick here, which is that I am done. And of course, I go back to the idle state in here. So let's take a look at the code very briefly. The code is very, very similar to the transmitter part or the receiver part. So it's also parameterized d bits to reflect the number of data bits I want to send, including parity or not. In my design, I'm basically just ignoring parity. And then here is the stop bit tick. I called it 16 because I want exactly one stop bit. And then here are the inputs and the outputs. They follow the diagram. And everything you see in here is exactly like the receiver. It's just a finite state machine. We have state register. We have that register S, the N, the B, and we have these two here, which is the TX, which is this particular output in here. And it's not the same as the reset because in the receiver, because in the receiver we didn't have any. These are what we call more outputs in here. So in here I'm just defining these more outputs, and you can see it like it's the same exact thing. We're gonna say this is the idle, this is the start, this is the data, and this is the stop. I recommend that you pause the video, take a look at this ASM chart or the ASMD chart. Remember, it's like moving data, that's what the D stands for, and just take a look at the code and just make sure that it follows and it makes sense to you.